Okay, so let's try this one. So we want to prove sine to the fourth minus cosine to the fourth equals sine squared minus cosine squared. Few ways I can do this, but I'm going to kind of look at this and notice that this is a difference of two perfect squares. Hopefully you all remember difference of two perfect squares, like x squared minus 9. Factors to square root minus the square root plus the square root. So what is the square root of something, or what is the square root of something to the fourth? What would the square root of x to the 4 be? Square root of x to the 4 would just be x squared. So this is a perfect square, this is a perfect square. So I'm going to factor this to the square root minus the square root. Ooh, that's a cos. Sorry, cos squared theta and square root plus the square root. Kind of like I did here. And the reason I wanted to do this, I saw it was to the fourth. And I'm like, well, if it's a difference of two perfect squares, I'm taking the square root of it, so I'm gaining x squared, or I'm gaining sine squared. So I know that sine squareds and cosine squareds sometimes give me things. And here they do. Sine squared plus cosine squared is 1. So I just have sine squared theta minus cos squared theta times 1, which again equals this, because anything times 1 is itself, so I'm done.